Let's talk about the JVM architecture in detail. In the previous video, we talked about the class loader part of this architecture and we discussed the JVM functionality, the two-stage process of its overall work, interpreting, class loading, and then executing the bytecode. The JVM specification provides the hardware platform specification to which you compile all your Java code. It provides a runtime environment in which Java bytecode can be executed. This specification enables software programs to be platform independent because compilation is done for a generic machine JVM. So the JVM provides a layer of abstraction between the Java application and the underlying operating system and hardware, allowing Java code to be run on any platform that has a JVM implementation. Now, this JVM architecture consists of several components. The first one being the class loader that we have already discussed. It is responsible for loading the Java class files into the JVM. It reads the class file from the file system or network, verifies them, prepares them, and then load them into the memory. So JVM is a key component of the Java programming language that enables the execution of the Java bytecode on any platform. JVM has its own memory management, which is divided into several components. So we have the JVM memory. JVM memory is the runtime data area or the memory area, as we call it as a memory area as well. It is divided into the five parts: method area, heap, stack or JVM language stack, PC register, and native method stacks. Now, what is method area? This is the memory area where class level data such as class definitions and method definitions are stored. The next component is the heap. This is the memory area where the Java objects are created and stored. The heap is divided into two regions: the young generation and the old generation. The young generation is further divided into two regions: Eden space and survivor space. Then we have the stack. This is the memory area where Java methods and local variables are stored. Each thread in a Java program has its own stack. After that, we have the PC registers. This is a small amount of memory that holds the address of the instructions currently being executed by a thread. And then finally, we have the native method stack. This is the memory area where Java code interacts with the native code. So this is the whole arrangement of the internal memory of JVM. It is divided into five regions, each performing a specific task, managing the memory of the internals of the Java program. The next step is executing the bytecode. And here comes the role of an execution engine. So execution engine is a key component of the JVM memory architecture. It is responsible for executing the compiled Java bytecode instructions. We can say that the execution engine is the central component of the Java virtual machine as it communicates with various memory areas of the JVM. When a Java program is compiled, it is translated into bytecode, which is a machine readable format that the JVM can understand. And it is the execution engine that reads the bytecode and executes it one instruction at a time. So the execution engine here consists of three main parts: the interpreter, just in time compiler, and the garbage collector. Interpreter reads the bytecode instruction one by one and executes them. Interpreter is relatively slow, but it allows the JVM to execute code on any platform without the need for recompilation. Then it includes the just in time compiler, the JIT compiler as we call it. The JIT compiler analyzes the bytecode and identifies parts of the code that are executed frequently. It then compiles those parts of the code into native machine code, which can be executed directly by the CPU. This can significantly improve the performance of the Java program. And the last component, which works inside the execution engine, is the garbage collector. It's a program that manages the memory automatically. Basically, it's a daemon thread which runs in the background and it frees up the heap memory by destroying the unreachable methods. So, other than the execution engine, we have the native method interface and the native method libraries as well. Now, what is native method interface? The native method interface or the Java native interface JNI allows Java code to call native code written in other languages like in C or C++. The JNI provides a standard interface between the JVM and the native code. That's why the code written in other languages can be executed by the Java applications. The JNI is a set of interfaces that permits a native method to interoperate with a Java virtual machine in numerous ways. For example, the JNI includes interface that create new objects and call methods, get fields, set fields, process exception, manipulate string arrays, and all that. To support that functionality, we have the native method library as well. The native method library contains the implementation of the native methods called by the JNI, the native method interface. So, a Java library, as we know, is a collection of the classes that have been written by somebody else already, and we simply use them for our purpose. So, for the purpose of the execution of the native code from the Java virtual machine, the Java native interface uses the Java native method library. That's all about the JVM architecture. The different components of the GM architecture works in a sync with each other and provides the functionality that we all use and are using for decades. So let's conclude it with a definition provided by the Wikipedia. A Java virtual machine is a virtual machine that enables a computer to run Java programs as well as programs written in other languages that are also compiled to Java bytecode. The JVM is detailed by specification that formally describes what is required in a JVM implementation. That summarizes the whole idea behind the JVM. So, overall, we can say that Java virtual machine architecture is designed to provide a secure and portable environment for running Java code on different platforms. That's the unique thing about the JVM.